In this lecture, we will talk about surface phenomena of contact angle. So at the end of this lecture, the student is expected to understand and able to explain conceptually about contact angle and able to relate the concept of a contact angle in pharmaceutical application. So please remember this, that the Mother Nature drives all systems to a minimum energy state in order to minimize surface energy of all matters. So with that, you have what you call surface tension. So when two surfaces met, then you will have what you call interface. Okay, let's say you have a droplet or a droplet of water that touch or meet another surface, for example solid. Okay, for example here is a solid and you have a water. Okay, or in this example you have the leaves here and you have the droplet of water here, and this droplet make up of certain contact angle to the surface of the solid or surface of the leaf. Alright, so the contact angle is an angle that a small drop of liquid makes as it meets the surface or interface of another phase, which is usually solid. Okay, it is always measured through the droplet or either air bubble. So first here they measure through droplet, and here let's say you have a solid that immerse, okay, in a liquid of water, for example, and if there is a air bubble form underneath the solid, then this will be their contact angle. Okay, so mathematically, contact angle is closely related to surface tension, or it is a function of surface tension. And how it is related to surface tension? Okay, let us visualize the droplet on top of a solid here. So you have the solid with the surface like this. Alright, so when this droplet meet the solid, and you will make a certain angle. Alright, so at equilibrium, all forces are in balance. So forces vector on the right will be equals to forces vector on the left. Okay, so what are the forces on the right? So the forces on the right will be the one here, okay, and this one, okay, and forces on the right will be on your left, sorry, will be this one. So forces on your right, okay, which is surface tension of the interface of liquid and solid. Okay, so on the right will be surface tension of liquid and solids plus, okay, we take the vector of surface tension liquid cos contact angle. So surface tension of liquid cos theta equals to the force on your left, which is the here surface tension of your solid. Alright, so if I have surface tension of your solid. Okay, so this equation is what you call Young-Dupree equation. So once again, at equilibrium, the relationship between the contact angle and surface tension is represented by Young-Dupree equation. Okay, so you should know how to derive this equation.
Contact angle indicates how repellent a surface is to a certain liquid. DFI coatings are both hydrophobic, water repellent, and oleophobic, oil repellent. Since the primary liquid our coatings are exposed to is water, we most often test using water. Therefore, when we report contact angle, it tells you how strongly the surface repels water. The higher the contact angle, the more the coating is repelling the water. Scientists measure contact angle on a special machine called a goniometer. This machine measures how high a bead of water stands up on the surface. As you can see, the contact angle of water on DFI protected surfaces is much higher. The higher the contact angle of water, the better the coating.
So in the lab, this is the machine that we use to measure contact angle, and here you have the camera that they will capture the droplet, all right, from here, and here you have a needle dispenser where you have a droplet from here, and it will be captured by the camera. So what is a practical application of Young-Dupree equation? If you rearrange the equation, you will have cos theta equals to surface tension of solid minus the interfacial tension between a liquid and solid divided by the surface tension of liquid. So for water wetting to improve, okay, on a certain surface, you need to have the contact angle smaller, so meaning that the water can spread better on top of this solid, so the contact angle need to be smaller, and hence your cos theta will be higher. So how you can do that? You can do that by increase the surface polarity, which you could actually increase the surface tension of the solid, or you can decrease the interfacial tension between liquid and solid by adding surfactants, or you can reduce the surface tension of the liquid itself, which is also by using surfactants. To recap, this contact angle is the angle that a small drop of liquid makes as it meets the surface or interface of another phase. So if you still remember, this is the Young-Dupree equation. Okay, since contact angle is closely related to the surface tension, and surface tension is also closely related to the work of adhesion and work of cohesion, if you still remember our previous lecture to talk about the work of adhesion, the equation for work of adhesion is equals to work of adhesion between solid liquid is equals to the one they generate a new surface minus the initial surface. So the new surface is the surface tension of the solid plus surface tension of the liquid minus the interface surface tension of solid liquid. Okay, so if you replace the equation of surface tension of liquid using Young-Dupree equation, you will have surface tension of solid, okay, surface tension of solid liquid, plus surface tension of liquid. Okay, so I take liquid as liquid because liquid vapor is equals to liquid, cos theta plus surface tension of liquid minus surface tension of solid liquid, which is interfacial tensions. Okay, so the interfacial tension minus interfacial tension, so we cross out. Okay, so you have the surface tension of liquid cos theta equals to surface tension of plus surface tension of liquid, which is equals to surface tension of liquid cos theta plus 1. Okay, and if you want to make it look nicer, you can just rearrange surface tension of liquid 1 plus cos theta. So with this formula, let's say you are given the work of adhesion between a solid and liquid, and also the surface tension of the liquid, then you can actually able to calculate straight away the contact angle. Or if you are given the contact angle and surface tension of the liquid, then you can straight away calculate the work of adhesion. So let's say now you have case 1, case 2, and case 3. When you have the same liquid, okay, here is the same liquid. So what happened to the solid? Then you will observe from case 1 to case 3. So when you have the same liquid and the contact angle is reducing, okay, contact angle reduce, this means solid surface energy is increasing, which means solid surface energy of the case C is higher than, so case number 3 is higher than case number 2 is higher than case number 1. Alright. However, when you have the same solid, okay, which you have same solid here, so what, in which condition that you will observe case 1, 2, and 3, that will be only happen when the liquid surface tension is decreasing. So if you are given this diagram and I ask you, when you have a same solid, okay, so can you tell me which liquid has the lowest surface tension? So it should be the liquid in case number 3, because the contact angle is smallest. Alright, I hope you understand. So in our daily life, there are some interesting observations on contact angle. For example, skin and water, you have the contact angle of around 90 degrees, because if it is 0, then all your external water could actually penetrate into your body. For example, Teflon and water. This is why Teflon is a non-sticking pan. Whatever that you cook on top of Teflon, it will not stick to your wok. Okay, for example, bird feather and water, and it has as high as the contact angle of 150 degrees. That's why when a bird, they touch the water, they won't get wet, or the swan or the duck, they won't easily get wet. It's just because the contact angle between the water and the feather is very high. So enough introduction about contact angle. What are the applications of contact angle? Okay, contact angle have most often used to estimate surface energy or surface wettability. Often it leads to classification of surfaces as hydrophilic or hydrophobic, or polar, non-polar, or wetting or non-wetting. For example, the pharmaceutical tablet. It is very particular whether a tablet can be easily wet or not if it is given orally with your water. Okay, it has to be wetted in order to dissolve into molecular level for absorption. So in practice, however, there exist many metastable stage of droplet on the solid, and the observed contact angle are usually not equals to the contact angle that we can estimate from the Young-Dupree equation. The phenomenon of wetting is more than just a static state. It is a dynamic one. Okay, the three-phase contact line. What is a three-phase contact line? Is the one that we use to derive the Young-Dupree equation. So you have one line, 2, and 3. This three-phase contact line is actually in motion. The contact angle produced is called a dynamic contact angle. So in particular, the contact angle formed by expanding and contracting the liquid are referred to as advancing contact angle and receding contact angle. Okay, and this angle fall within a range which with the advancing contact angle approaching a maximum value and the receding angle approaching a minimum value. And the difference between the advancing contact angle and the receding angle is called hysteresis. So hysteresis is equals to contact angle, advancing contact angle minus receding contact angle. So how you measure advancing contact angle and receding contact angle, we will cover in the next slide. So this slide show you the example of measuring advancing contact angle and receding contact angle. So when you measure advancing contact angle, liquid is introduced into the droplet, and the maximum angle made is the advancing, and for receding, we will withdraw the liquid from the droplet, and there will be a minimum contact angle which recorded by the machine. And now we measure advancing contact angle again. Okay, if you can look at this dynamic diagram. And now receding contact angle, the one here, receding contact angle. Okay. And once again, advancing contact angle. Okay. So advancing and receding contact angle arises from surface roughness or heterogeneity. For surfaces that are not homogeneous, there exist domains that represent barriers to the motion of contact line. Okay, so we finished the video, so let's go to the next slide. So in essence, advancing contact angle sense actually the hydrophobic portion of the surface property. So for example, you at equilibrium, this is water drop. When you add more amount of water to the drop will probe the hydrophobic region, and then you will stop there, and it makes an maximum angle. So they actually sense the hydrophobic portion of the solid. And same happen to receding contact angle, that it sense the hydrophilic part of the portion. So when you have the water at equilibrium and you try to withdraw the amount of water from this droplet, okay, and the drop is held back by the hydrophilic regions, so the contact point here represent the region of hydrophilic. All right. So this is an example of contact angle on hydrogel made by cross-linking 3 arms polyethylene glycol acrylate of different pg molecular weight. Okay, so this is their advancing contact angle and this is their receding contact angle. At a very small molecular weight, there is a very large hysteresis between advancing and receding contact angle, and when molecular weight increase, the hysteresis become smaller. So on a smooth but chemically heterogeneous solid surface, the experimentally observed contact angle might not be equals to the Young-Dupree contact angle. Nevertheless, the experimental advancing contact angle might be expected to be a good approximation of Young-Dupree contact angle, while the experimental receding angle is usually found to have less reproducibility due to the liquid absorption or solid swelling. Okay, there are as yet no general guideline regarding how smooth a solid should be for a contact angle measurement. Okay, and how they can have an obvious impact on the contact angle. It is therefore recommended that the solid surface should be prepared as smooth as possible, as inert to the liquid of interest as possible for measurements. So in pharmaceutical area, unfortunately most of our pharmaceutical material are powders, and direct measurement of individual particle is not usually possible. That's why it usually measure by compressing the powder into a compact. And the problem here is that the application of high pressure, okay, may change the characteristic of the particle and change the contact angle. What is the high pressure? The high pressure of tableting, for example, that actually compress or compact the surface. Okay, this may actually influence the final reading of contact angle. So here is an example for amylobarbital that the contact angle is measured as they change the pressure in producing the flat surface. So they use let's say a tablet punch to produce a flat surface, okay, and by changing the pressure of this punch, it changed the contact angle of water on top of this surface. So at low pressure, okay, the contact angle is very high, okay, and when you increase the pressure, okay, that the the surface of the tablets becomes smoother, and the reading for contact angle is much more consistent at the end. Okay, so there are several techniques for preparation of smooth homogeneous solid surface which has been developed. These include heat pressing, solvent casting, cell assemble monolayer, deep coating means you coat the surface, okay, or surface polishing, you polish the surface to make them as smooth as possible. So here list the concern and consideration of contact angle measurement. So we need to consider about whether the liquid penetrate onto the surface, whether the liquid dissolving the surface of a solid, whether there is contamination of the liquid that they can actually interact with the surface, and size of the drop and effect of gravity, evaporations. Okay, let's say if you measure your contact angle in a very high temperature country, for example in Malaysia, you have to keep your lab at a certain temperature so that your contact angle measurement will be accurate, okay, and it is usually limited to ambient temperature and limited to flat surface. Okay, you need to concern about the surface roughness, which you need to smooth them. Alright, surface heterogeneity, surface group mobility and kinetic, and also concerned about advancing and receding contact angle, but usually we measure advancing. Limited relativity low energy solids, and individual bias, eyeball bias. Because before we start to use the machine to measure the contact angle, we need to calibrate the machine, and the calibration is very much depend on individual eyeball bias. So one of the most important application of contact angle measurement in pharmaceutical is determination of solid surface tensions. So, however, solid surface tension cannot be directly measured since most existing technique of surface tension measurement rely on surface deformation, which is difficult in the case of a solid. Okay, so contact angle measurement is considered to be the simplest way in the assessment of solid surface tension. Okay, Young equation reveal the correlation between contact angle and interfacial tension, and it suggests that observation of equilibrium contact angle of liquid on a solid might be a starting point for solid surface tension in pharmaceutical. So how to measure solid surface tension? The pioneer works of interpreting contact angle in terms of solid surface was actually first carried out by this researcher and a co-worker in 1960. However, the theory behind how you can actually measure the solid surface tension, you need to use various type of organic solvent. Okay, then using equation to calculate to estimate the solid surface tensions. Okay, and however in pharmaceutical we concerned about the critical surface tension of a solid. Okay, and it is a function or an estimation of how water can wet your solid dosage form. Okay, this is what we really interested about. And in critical solid surface tension, the change of cos theta versus liquid surface tension, okay, fall into a linear trend for homologous series of liquids such as alkane on Teflon. So in addition, the extrapolation of linear curve to where cos theta equals to 1, which means when theta equals to 0, it will give an important parameter called critical surface tension. So now, let's say you have a homologous series of alkane, okay, and you have a surface of Teflon. So now you measure the contact angle between this series of alkanes on the Teflon, and you plot the graph on the contact angle. Then you will get what you call a critical surface tension. This will show in the next slide. Okay, here we have the surface tension of the liquid alone, which is the alkane, surface tension of the alkane alone. Okay, let's say we take one with around surface tension. This is surface tension of water, 72.8, and this is the methylene iodide drop, around 53 surface tension, and this one naphthalene drop around 40, this one around 35. Okay, and when you measure them on top of the surface, and they give you a certain contact angle which you can plot from here. So you have a plot here and another one you plot from here. Okay, then you get a linear trend, and this linear you can actually extrapolate. Okay, so you extrapolate to the intercept where the contact angle is equals to 0. Okay, then you got what you say here is around 26 contact angle, and here is what you call critical surface tension, right? So by knowing critical surface tension, theoretically a liquid with a surface tension equal, okay, or less than the critical surface tension would actually wet the solid surface completely. Okay, and in summary, the solid surfaces are required to be rigid, smooth, homogeneous, inert to the testing liquid, and in that case advancing angle should be used instead of the receding so as to minimize the possible swelling and physical, chemical effects. So here are some examples of liquids used in critical surface tension measurements. Okay, why we choose this liquid to be used for surface tension measurement? Because they are stable and they can be easily purified, and they have relatively low viscosity, low volatility, and only pure liquid will have a well-known surface tension. So here are critical surface tensions values for common material calculated from the contact angle measurement using the series of alkane. Okay, so please note that the range is relatively narrow. Okay, and with that I end my lectures on contact angle, and thank you for listening.